So on page 19, hopefully, I know your homework was just on page 19, but hopefully you guys were able to check the key on the next page, and hopefully all the steps make sense. So for 82, right, for P is referring to product rule, Q is referring to quotient rule. So once you build out your product and quotient rule, then you're just inserting whatever X value that's that the problem specifies, and then you're just either pulling the Y value or the slope, right? Depending if it's just F of X G of X, which is Y value, or if it's F prime G prime, then it's the slope. And then bottom of the page, we just look at how what relationship is built here. For 105, we definitely have to involve quotient rule. But for 103, this is just derivative rule, right? So 2G of X becomes just 2G prime, and H just becomes H prime. So we don't do anything special because these are just individual terms. So we just have to take the derivative, and then once we're there, replace all the X's with 2's, and then look at your values that's given, and just for making substitutions. So hopefully you guys find these pretty straightforward and easy. Any questions with product and quotient rule? Okay, so product and quotient rule is not too bad. I think what's more challenging is what I want to show you on page 20. So I don't think we started this, right? Did we do any on page 20? No. Okay, all right, good. All right, so let's practice this. Make sure that you're comfortable with this here. So it says that H is equal to F of G of X, and S is G of F of X. It says find H prime of 1. Okay, so obviously before we find H prime of 1, we first define H prime of X. But let's look at how H is defined. Now, if I want to find the derivative, is this product rule or is this something else? You guys recognize this? This is chain. Yeah, this is a function within a function. If it was product rule, you will see two X's. You'll see F of X times G of X. But this is F of G of X. This is chain rule. And we know chain rule is outside derivative times inside derivative. But we also need to know how to build the chain rule in function notation. How do we build that derivative? So let's do that. So outside derivative, we can tell the outside is F because that's the one that's outside the parentheses. So we do outside derivative, so F prime of G of X. Right, we said that when we take the outside derivative, we leave the inside term alone. And then once we're done with the outside derivative, then we move on to the inside derivative, and G of X becomes what? G prime. Yeah, so this is chain rule in function notation. We need to make sure we know how to use chain rule, but also to memorize the process of involving chain rule for function notation. Okay, so now that we have the derivative built, guess what our next step is? Plug in. Yeah, plug in 1 for all the X's. Okay, so okay, so this is where some of us may run into some issue in terms of what to do next, or making sure that we're processing this correctly. So in this sense, it's a little bit harder than product rule and quotient rule because it's not as linear, it's not as straightforward as those processes. So what I want you to first recognize is that there's a lot going on here, right? And we're not going to be able to do it all in one step. Okay, so let's break it down into easier steps. What are some things that we feel are manageable to find? What's a piece of this that is easy to find, we think? G of 1. Okay, so that's easy, right? What else is easy? Yeah, so we're going to find those two things first. Okay, it's not going to get you to the answer, but it will help you take the next step towards the answer. Okay, but what I don't want us to do is I don't want us to try to do it all in one step. If you try to do it all in one step, that's too much, right? Break it down into easier, more manageable steps. Okay, so G of 1, highlight those points there. Okay, so G of 1 is actually down here. All right, so what's G of 1 equal to? 4, right? That's the Y value. So what I'm going to do is I'm going to replace that piece, but I'm still copying everything else down, right? I haven't done anything with F prime yet. All I've taken care of is that G of 1. So I'm just going to copy everything else down. Okay, and then what's G prime of 1? -1/2. And that I can replace as well, right? Okay, I'll read good up to this point so far. Okay, so now it should feel easier because rather than something within something else, now this is just a straightforward F prime of 4. And if I can resolve F prime of 4, then I'll just have two numbers that I can multiply together, and that's my answer. Okay, so what's F prime of 4? Yeah, it's the slope of the F graph, right? And the slope of the F graph, this is just slope is down 1/1, so that's -1. So I replace that with -1. And finally, our H prime of 1 is just 1/2. Okay, thank you. Okay, how do we feel about this process? Okay. Yeah, so I think this is the trouble spot, trying to get from here to here. Sorry, getting from here to here. Once you're here, then it's a little bit more manageable. But just keep in mind that I can't do it all in one step, not like product and quotient rule. I gotta take my time with this. Do one piece at a time. And once you get that inside, then this portion feels easier. And then you can kind of work your way down to a number answer. Okay, can you guys try part B? Build your derivative, plug in 5, and then see if you can do piece by piece, just like this one. So give you guys a start on this, and I'll walk through it as well. Okay, are we good so far? Building the derivative using chain rule. Well, first recognizing that there's chain rule involved. All right, so I want to make sure that we understand that product rule kind of looks like chain rule, but product rule has 2 x's. Right, chain rule only has 1 x. Okay, everybody good building this derivative? Okay, replace every x with 5. Okay, do what feels easy. The f of 5 and f prime of 5, right? Those feel manageable. right, what's f of 5? 6. Now, when you find that value, copy everything else in front of it because we haven't done anything with g prime yet. All we've done is we figured out f of 5. And what's f prime of 5? Yeah, -1. Okay, but we're going to run into an issue here. Okay, so next step is the last thing to do is to resolve this, the last piece to help us get to our answer. So g prime of 6 is asking not for the point, it's asking for the slope. G prime of 6, what do you notice there?
Sharp turn.
Sharp turn, right? If there's any corner, the graph is not differentiable, which means that the slope is what? Undefined. And if any part of your process gives you DNE, then the whole thing breaks down. The whole thing does not exist. I can't have, oh, DNA here, I can cancel does not exist between two terms. And yeah, if any part of it does not exist, then the whole thing does not exist. Doesn't matter if this one still exists. G prime of 6, slope is undefined at a corner or at a sharp corner. Okay, so I think on the test and quiz, it's the chain rule that gives students more trouble than others. So why don't we do a couple more chain rule and just really get comfortable with it? And I'll show you different couple of variations as well. So on page 23, why don't we go through a couple of those problems? So let's try B, D, and 115. Okay, it says find f prime of 5 for each. Okay, think multiple steps. Let's do the things that feel manageable, right? We can't do all this in one go, but we can find what h of 5 and h prime of 5 is. The good thing is there's no need to read the graph. We just have to find those values. So h of 5 is 3, h prime of 5 is -2. We make those substitutions, but make sure you don't lose this. You're still having to resolve this for later. Okay, so now this feels a little bit easier, right? We know that h of 5 is 3, so now g prime of 3, something that we can find and look for. So there is no G prime of 3, which means that this is going to be part of our final answer, right? If we don't give that to us, then we have to leave our answer in this form. So F prime of 5. Now, if there was G prime of 3, then that's great. But if not, then this is as far as we can go. Now, part D is also chain rule, but what's different about this versus B? Okay. Yeah, there's only one function in function notation. So this is a bit of a mix. You have an outside function that we can actually do a derivative rule for, but the inside function is function notation. So it's not like this one where the outside and inside are both function notation. This one, the outside we can actually do power rule for. The inside we have to leave alone. So let's go ahead and thank you. But this is still chain rule, right? You still see that outside inside portion, but here the outside we can actually do something with in terms of power rule, but the inside we'll leave in terms of just function notation. Okay. So let's take turns with each derivative here. Okay, what's parentheses or bracket cubes derivative? Yeah, 3 parentheses squared. We leave the inside alone. We're not ready for that yet. Times, now we're ready. Yep, now ready for inside derivative. So G becomes G prime. It's a little bit different than this one, right? Before, this one was function notation, so we just say G prime h of x, but this one we actually can find a derivative, so we have that power rule going here. Okay, so now replace every x you see with 5. And then you look for those values, right? G of 5, -3. G prime of 5 is 6. Ends up being 9 times 3, 27 times 6. Okay, back to graphs. So 115. Can you guys try A and B, and then we'll walk through it, make sure that you guys feel comfortable with chain rule on page 115. And then page number 115, and then the key is on the next page, page 25. Right. Hopefully we recognize the need for chain rule for both of them because these are both function within a function. Okay, g of 1 is equal to 4. G prime of 1. What's g prime of 1? 0. Now we know it's going to be 0, but I think it's just good to make sure, get that practice in, right? To if we were to go a little further here, f prime of 4 is asking for the slope of the f graph at 4. You see that 4 doesn't line up nicely at a point, so you can just see if we can find 2 points. So looks like I have to rely on the endpoints here because nothing else looks like it's lining up nicely right at a coordinate point. So I did rise over run. So I went up 5 over 4. I know it didn't affect the answer, but I think it's good to kind of finish that whole process there. Okay, you guys feel okay about this type of problem? You'll see this on the test, so I'm gonna make sure that every piece of this process feels manageable to you. Okay, all right, let's look at part B. Okay, f of 4 lands right between 2 and 3, so 2.5 or 5 over 2. And then f prime of 4, the slope of the f graph at 4, okay, same as what we found over here, right? 5/4. So now g prime of 2.5. So we go to g 2.5, which is right here. But as long as we can find the slope of this line, then we can find the slope at that point, right? Even though it's a decimal, but it's all the same slope here. So 1, 2, 1, 2, 3, 4. So 2 over 4, slope of this line is 1/2, right? Yes, question.
How do you get 5/4?
Oh, so 5/4. I'm asking for the slope of the f graph. And I'm just trying to find 2 points where I can do rise over run, but it's hard to find 2 points that are easy to spot. So I just use the endpoints. So because I mean, all these points doesn't seem to line up nicely. So, but I know these two line up nicely. So I just count from one end to the other and I count it out 5 over 4. Everybody good? Okay, so there's 2 more things that I want to go over with you, and we'll have kind of seen everything. So let's go to page 24. You pass it. think I briefly talked about this yesterday about how we find horizontal and vertical tangent lines. So vertical tangent lines are places where the slope is undefined. So we set the denominator of the derivative equal to 0 to find places where we have vertical tangents. So let's say the graph looked like a circle. Your horizontal tangents would be places where your slope is 0. So you're basically looking for these places, right? Slope 0 will be where those points are. Vertical tangents will be places where my slope is undefined, and anywhere I can draw a vertical tangent is where I'm getting slope undefined. So if I want to find the locations of these points, this is how I would do it. So we're going to find the derivative first, and then most likely we're going to get a derivative that is a numerator and a denominator with a numerator and denominator. So then if we set the numerator of the derivative equal to 0, that's going to help us find horizontal tangent. That's going to help us find these places where the slope of our graph is 0. And then if there is a denominator in my derivative, then if I set that denominator to equal to 0, that's going to help me find the places where I have vertical tangents. But first things first, we have to get to the derivative. To get to the derivative, look at how this is set up here. We have to go through what to find the derivative. A process here. Implicit, yeah. You see y's mixed into the equation, right? It may not be attached to an x, but you see y squared. You see multiple y's. That's, you know, any of those is enough for us to know. Okay, we got to go through implicit. Okay, but the nice thing is everything is power rule. There's no product rule here. Just have to go through power rule. Okay, let's do that. So nothing special with the x's. With the x's, we just find the derivative, but with the y's, we need to attach dy dx. Now, how many dy dx's should we expect? 2. Yep, you see 2 y's. You're expecting 2 dy dx's. Okay, so try that. All right, collect my dy dx terms. Move the non-dy dx terms to the other side. And I'm doing 2 things at once here. I'm going ahead and just factoring out that dy dx. Okay, so I have my slope formula, right? My slope formula, if I plug in any x and y value, it'll give me a slope. But we can also go backwards and say, you know, we're looking for specific slope behavior, and then we're going to go backwards and solve for the x and y. So let's do the horizontal tangent first. So if I want to find horizontal tangents, places where my slope is 0, then how would I go about doing that? Set the numerator of the derivative equal to 0. Okay. Now here's my my directions, by the way. The direction says find the points. So once we solve for whatever variable we're solving for, we're going to insert back into the original equation to actually find these points, because there could be more than one point. But after we find the horizontal tangent, then we can go back to the original equation. Okay, so the numerator, yep, set the numerator of the derivative equal to 0. That can help us find these places where slope is 0. Divide both sides by -50, x equals what? -4. Now, -4 is not the full order pair. It's asking for points. So if I want to find the full location where there's a horizontal tangent, what am I going to do with this number? The original. Yeah, back into the original. It's a little bit numerically messy, not messy, but it's just a little, I'll just kind of walk through the steps here. So if I replace every x with -4, there's only going to be y's left over. So I'm going to get 400 plus 16y squared minus 800 minus 160y plus 400. So something's, well, the nice thing is that the numeric values cancel out. I'm just left with 16y squared minus 160y equals 0. I can factor the 16y out because there's no constant for me to move over. There's just two terms here. Just take the GCF and then set both equal to 0. 16y equal to 0 and y minus. So if I have two y's, I'm looking for there's two different y locations. So 16y equal to 0. Divide both sides by 16, y equals 0. Y minus 10 equal to 0. Solve for y, I get y equals 10. Now this is all coming from when the x is -4. So when x is -4, there's two different y values. It's okay to have 2 points above each other. This will fail the vertical line test, but I mean, we're doing implicit, so we kind of already knew that this was not going to be a function. So there's two places where there's a horizontal tangent. Okay. -4, 0 and -4, 10. So this actually ends up being the shape of an ellipse. So there's two places where you're going to get slope 0. Slope 0 is going to be directly above each other. Okay, likewise, if I want to find places where there's a vertical tangent, I can do what? Denominator of the derivative equal to 0 and go through the same process. It may give you a different variable value. If that's the case, it's okay. Just plug that back into the original equation. And if there's more than 1 point, then you're going to get two different x or y values. Okay, so vertical tangent, I set the denominator equal to 0. In this case, it's the y variable that I'm solving for. I'm solved for y equals 5. Now 5 is only a partial information about the actual point. In this case, I have to go back and look for the x. So if I'm looking for the x, back into the original equation. So just to speed up the process here, if I plug in y, well, the nice thing is, looks like all the numbers go away. I'm just able to get it down to 25x squared plus 200x. Factor out the 25x. There's two different x's, so there's two different x solutions. 25x equal to 0, divide both sides by 25, I get x equals 0. X plus 8 equals 0, I get x equals -8. So you have two vertical tangents as well. It makes sense, right? If you picture an ellipse, you're gonna have two places where there's a horizontal tangent, and there's two places where there's a vertical tangent. Okay, I went through it a little fast, but the key is attached on page 26. But do the steps make sense to you? And then we can always practice 58 later, but we can just want to make sure I get in a full example with implicit, with horizontal tangent, vertical tangent, and then knowing how to find the full order pair, putting it back into the original equation to find that full point. Okay, good. There's one more thing that I want to show you. This may take a bit more time, but I want to walk you through the process, and we can practice, do one today and practice one tomorrow. Okay, page 27. Okay, I want to include this as part of test content because AP exam loves to give these types of problems. Okay, and if we know how to do it, then we can kind of just review it when we need to review it second semester. But having said that, students struggle with this. Okay, so I want to see where we stand, and if you have questions, I want you guys to ask those questions. But I don't think it's hard, but I understand this is something new, so it's going to feel a little weird in terms of a little bit different than what we've seen. Okay, so here's the concept: is that it says find the constant that makes the piecewise function continuous and differentiable. So understand that we're trying to force continuity and differentiability in here. The A and B are not defined. They're not set in stone. We're trying to figure out the A and B values so that this can happen. So let me tell you what we want the graph to do. We want the graph to not only connect between these two branches, but also connect in a way where the Y values are the same, but then also what is the same? Yeah, good. So we want the two graphs to share the same Y value at 1, but also share the same slope at 1. Okay. So the way that we're going to force this to happen is we're going to do two things. There is the continuity portion, which is where we're trying to force them to share the same Y value. And then there's the differentiability portion, where we're trying to force them to share the same slope. Now, the same Y value is pretty easy. We just have to set the two equations equal to each other, replace one for X, and then we'll see how that plays out. But we know that these two graphs, if we want them to share the same Y value, we can just set them equal to each other. So that part, we're not going to have issues with. Now, are they going to share the same Y value everywhere? It's only when X is what? When X is 1. So we can go ahead and replace every X with 1 because we only need them to share the same Y value at X equals 1, right? Anywhere else, they're not going to, we don't care if they share the same Y value or not. So go ahead and replace every X value with 1. Okay, are we good so far? So we haven't done any calculus yet, but we have done a good portion. Now maybe I can clean this up a little bit here. Combine like terms here. I'll make this A equals 1 plus B. But ultimately, I need some help, right? I can't solve for A or B because I need a second equation because I have two missing variables. Are we good so far? So now this is where the calculus comes in, the differentiable portion. Now, if we want them to share the same slope, slope is going to come from the what of the function? Derivative. Okay. Now, A and B are constants. Okay, so you're going to treat A and B like as if they are just numeric values. So pretend A and B is just a 1 or 3 or 5 or 6. We just don't know what those constants are. Let's build the derivative first. All right. So all I'm doing is I'm just going to find the derivative of this, call it f prime. And once we have the f prime piecewise functions built, we'll set them equal to each other and we'll repeat the same process here. Now, what's the derivative of ax plus 3? Okay, so imagine this. What if I ask you what's the derivative of 4x plus 3? 4. Okay, so the derivative of ax plus 3 is a. Good. So I know it's weird, but we just have to. They like to do this on AP exams, just kind of involving these unknown constants. But if you see an unknown constant, just pretend like it was a 4 or 5 and just treat it the same way that you would. So the derivative is just a, right? Okay. All right, so now the second expression here, we're also going to find the derivative. Power rule will help us get through each of these. Okay, so 3x squared becomes x becomes 1. B becomes 0, okay? Students struggle with this because they see a letter like X and they want to say it's what? Students want to say B is equal to, B becomes 1, but it's not 1, okay, it's 0. B is a constant, it's not a variable, so B goes to 0. So X. So now we have the derivative. Guess what we're going to do with these two? Set them equal, yeah, because we're trying to force the same slope between these two derivatives here. But we only care about them sharing the same slope when X equals what? 1, yeah, so I can replace all the X's with 1. In this case, I know there's only one X, so A is equal to 6 times 1 plus 1. Okay, sometimes, so this one is nice. This one just solves A easily, and I can just use that to solve for B. So now that I have A solved, it's going to help this other equation out. If I plug 7 in for A, this, if I had to choose the one thing that students struggle with the most on the test, is this one right here. But if you just understand that A and B are just constants, and if you know how to set it up, it'll be just like this. Okay, set the equations equal to each other, replace whatever X value they give you, set the derivatives equal to each other, replace X for whatever they give you, and then see how they can help each other out and solve for the two missing values. Okay, we'll do some more practice with this, but I think we've seen everything. We're going to practice tomorrow, Thursday, and then that's Friday. I have a help session tomorrow morning, 7:30, and Wednesday afternoon, 4:30. All right, come get your phone. No homework tonight, but if you guys can do some practice, that'll be good. So.